In this workshop, we're going to solve the problem to figure out who Brown, Jones, and Smith are. Brown, Jones, and Smith are suspected of income tax evasions. They testify under oath as follows. Brown says Jones is guilty, let's denote that by not J, and Smith is innocent, let's denote that by just S. So Brown makes the statement not J and S. Jones makes the statement if Brown is guilty, which is not B, then so is Smith, that's not S. So Jones makes the statement not B implies not S. Smith says I'm innocent, but at least one of the others is guilty. In this case, Smith says Smith is innocent, but one of the other, at least one of the other, is innocent. So we're going to consider two cases. Assume that everyone is telling the truth. That's going to be an easy case for us to handle. Assume that the honest told the truth and the others lied. That's going to be a harder case for us to make. So let's take a look at how we approach this. Suppose everyone is telling the truth. So if everyone is telling the truth, then B says Jones is guilty and Smith innocent. So we assume it's J and S is true. Jones is guilty. J means not J is true and S is true. Jones says if S is innocent, so it says Smith is innocent, then B is innocent. If you believe that John is telling the truth, then we have to believe that B is also innocent. Therefore, under these two conditions, we have come up with a situation where we know S is innocent and B is innocent and J is not innocent. J is guilty. Another question is this condition is consistent with the statement made by Smith? Smith says, I'm innocent, which is true, and one of the other ones is guilty. That's also true, because we know J is guilty. So therefore, in this case, if we assume that everyone's telling the truth, we come up with a solution that S is telling the truth, S is innocent, and B is innocent, and J is guilty. So the other ones are much harder. Suppose assuming the honest told the truth and the others lied, we have to consider many cases. In other words, we actually have to consider 7 possible cases for B, J, and S. So let's consider the first case and see why this could be a possibility. Suppose B is telling the truth, and J is telling the truth, and S is lying. So what this means is that B is always telling not J and S. And J is saying not B implies not S. S, because we know it's lying, S is saying S and not B or not J. Because it's lying, we're saying it's not of that. And because J is innocent, J is innocent, which is true, therefore not true is false, and therefore this whole thing is false. And therefore it doesn't matter what the other things are, because we have an AND operation, the whole thing is false. So therefore it couldn't be this one. Let's take a look at another one, and I'll leave the other ones for you to consider. Suppose you assume that B is telling the truth, and J is lying, and S is telling the truth. In that case, we believe what B says as it is. Since we think J is lying, we take the negation of what J said. J said that not B implies not S, which would be the same as saying S implies B. We take the negation. And then we take because we assume that S is telling the truth, we take the statement as it is. And then we can show that this is not consistent, because if you use the rule, which is this rule here, not of S implies B means not of not S or B. We talked about this in the lecture. S implies B means not S or B. And so we take the not of that. And using this rule, which we will talk about later in the class, we take not P or Q is not P and not Q. So in this case, not of this means not S, which is S, and not B. So we get this one here, which is going to be false, because we know that S is true and not B is false. Therefore, this is false, and hence this whole thing is false. So this is not consistent, this is not consistent, and I will leave to you as an example, as an exercise, if B is telling the truth and J is lying and S is lying, and you can still show that these three conditions cannot be consistent. The other case is FTT. Again, you could show that these things are not consistent. I ask you to try those things. The only thing consistent in this case would be FTF. So we have to assume that BJS are FTF, and then we ask the question, is this all consistent? So I congratulate myself on saying, very, very nice argument, Professor Guna. So you can show that this is the only thing that would work for you. That means Brown is lying and Jones is telling the truth and Smith is lying. So therefore, if you assume that some are lying and some are telling the truth, and we have come up with this. And you should be able to show, again, that assuming this combination, this set of constraints cannot be consistent, and this set of constraints cannot be consistent. So if you like, you can stop the video and pay attention to these things that's written, and you do it yourself. This way you can learn. So the approach I took is, in the case that if you assume that the honest told the truth and the others lied, then I looked at the 7 possibilities where someone lied. And then I looked at all 7 possibilities and thought, what can I say in terms of these 7 possibilities and the statements people made? One key thing I did was, if I assume that the person is telling the truth, I would take the assignment, I would take the statement that person made as it is. If I assume the person is telling the lie, then I took the negation of that statement because I know the negation has to be true. So those are the arguments you have to make to remove things that are not consistent. So in this case, I hope you will try these 7 possibilities and come up with this is the only combination that's going to do the thing for you. This is another problem which is very similar to the problem that we just discussed. So in this case, tourists come to a junction. There's a people in this village who either always lying or always telling the truth. And the question is, what is one question tourists can ask so that if the answer is yes, he will go left. If the answer is no, then he will go right. So let's think of a way to organize this. Tourists need to ask a question so that if the answer is yes, then he goes left. And the answer is no, he goes right. In other words, whatever the question this person is going to ask must have 2 options, regardless of the person is a liar or truth teller. So we have 4 possibilities. Let's assume that the left is the right road. Left is the road that's leading to the city. And if you ask the truth teller, the left road is, that truth teller will say yes. But if you ask the liar, the person will say no. If you ask the truth teller if the right road is leading to the thing, if you ask the truth teller is the left leading to the city, the truth teller will say no. And the liar will say yes. So we have these 4 possibilities and we want to formalize this statement. And let's suppose that P is a truth teller and Q is the left road leads to capital. So liar is not P and right road leads to capital means not Q. So in fact, if you think about this, you can say a direct question a tourist can ask is, you can ask the question from this person, are you a truth teller and is the town on the left, which is this option here, or are you a liar or is the town on the right? And by looking at this very carefully, you will see that this question, this is one question which has 2 parts, will be able to determine if you get the answer yes to this question, then we know the town is on the left, regardless of the person who is answering that question. If you get the answer no to this question, then the town is on the right, regardless of the person who is answering this question. So all these problems that we looked at are really binary decision problems, and in order to be not confused, you must have 2 options and very keen things that you're trying to determine what these people are. If you have any questions, you can post comments to this video.